Okay, the topic of my presentation is how to smoothly migrate the legacy code tool. By the way, how many of yours were on the previous presentation just before something about the it was about transformer, the time to start from scratch. It was like 1 hour ago. You were over. There would be some similar moments. I will repeat some of the concepts, but I will mostly focus on the technical part of it, related to Python. But let's dive straight into it. Okay. My name is Andrii. I work as a software engineer at STX Next, and the agenda looks the next. By the way, it's really not the best way to place because I don't see the slides on my laptop. But yeah, the main reasons for code refactoring, we'll talk about that. We will clarify quickly what the legacy calls, what does it mean, how to, a couple of great ideas, how to refactor that code and the outcome in 90% of them, if there were not strong reasons to refactor, how to minimize treats, and the technical part where I will show you some of the use cases which we used in my legacy, extremely legacy code. How do we move from one legacy tool to another one? Which patterns do we use? How that migration may look like when you work on the monolithic architecture and in microservices. And there would be the exact use case that I mentioned before, when we migrated from zero-in-queue message broker to the NAS. Okay, let's move on. There are a couple of reasons, there are a number of reasons why you can consider refactor your legacy code. And I can say that each of those that you can observe on the slide might be valid as well as not valid at all. It strictly depends on your project needs, on your business value, and I will talk about the business value in a moment. But it's worth to mention at least a couple of them. You want to adapt to changes, you want to refactor your code because to adapt to new requirements that comes from the business side. You want to improve performance. It's not that just your code inefficient, but it's just really slow. You want to optimize you're just not able to handle the current traffic. You want to improve code maintainability. It's easier to maintain the clean and well-organized code. It's pretty much obvious. But refactoring that, you also can reduce the technical debt and make the future changes easier. You can make your architecture more modular, which will increase the maintainability. Reduce complexity. I don't think that we need to go that much into details, and I hope that it's clear for you. Or the improved readability. Okay, what are the core components of each refactor? And I really think that at least two of them. I want to pay attention that each refactor, it's not that just we developers struggling with something, but it's really two components. It's the technical value and the business value. Those two things cannot live without each other. And for the technical value, you can think as a reinnovation of your code. We are not just simplifying things, but we are turning our software in the high-performance machine. But that is what about the technical side. But if you think about the business value, you should actually think about the business value of your refactors, because it's a forward-thinking investment. When you, as a business, you invest into the refactors, it will save your costs in the future, most likely. I prepared that picture. I think it really makes sense, because for the successful migration, it's like you need both the good vehicle and the well-specialized driver for a good trip. The same in software. In order to have a successful refactor, you need to prove the business value. Yes, it's the reality that all development is living, like we develop things, only because our business that we develop earns some money, and we just develop things. Okay? Legacy code, what does it mean? Yeah, I tried to be funny here and not explaining you the simple terms. But yeah, the testing part, and the one thing that distinguishes the legacy code from non-legacy code is that usually it doesn't have the automation tests, the release phases takes extremely long time. There is no sometimes unit tests, please believe me, there are sometimes not even no unit tests, which is extremely bad. And I would like to strongly convince you to write unit tests before you even start refactoring your code. Even it's extremely bad and hard, it will prevent and save you a lot of money, everything, by the way. Lack of documentation and README files. This is also kind of interesting one because the documentation, the heads of your leads managers is not the best place for the documentation. Because if they leave their company, then the documentation just gone. It's just simply if you have a memory Redis, which you turn down, and the documentation gone. Hard to debug. Yeah, pretty obvious issue. It's really hard to debug any issues or your environment just not optimized to the normal debugging process. You don't have logs. Yeah, there are a number of reasons, but if you spend a lot of time trying to find your bugs, then something wrong. Okay? Adding new features to legacy code take enormous amount of time. Yes, because you need to prove your business that you want to deliver some features. You need to deliver them in normal time, like you have that story points, grooming, and if you're constantly not delivering the things, then something is wrong. But the business sometimes decide, no, we will not waste money for the refactor. We will, let's keep it like that. But yeah, obviously it's a mistake. Apps code not optimized for the current traffic, and yeah, obviously it's not a solution just to add more instances, but yeah, you have a poor scalability issues in your code that you can't just scale. And yeah, the last one from that series, you just scary to make changes on your code, because the code base just smell. You really scary to make any change because you don't want to break something. All components are tightly coupled, but you just scary to make any change. Cool. There are a couple of more. The legacy, you don't have a planning and design behind the scene. You have numeral numbers of dependency and highly coupling. The documentation with excuses more than the real comments and valuable comments, or the library versions are outdated. That is also might be a strong reasons. Okay, a couple of ideas that you might hear. That let's start from scratch and rewrite the entire code base, or let's use this fancy tool, it's super fast. Or Python is slow, let's use assembly. All of them, you might hear them, and sometimes it's even work, sometimes it isn't. But I would strongly convince you that for each of those ideas, you really need to align with the business, you need to align with all the verbs, do we really need that? Or the ideas should not come just, I like that fancy tool, let's introduce it. The outcome, unfortunately, I faced that in my career, that that idea without strong background just doesn't work. And usually, when it doesn't work and the company wastes money on that refactor or introducing a new feature on top of another bad feature, and when it doesn't work, the company will anyway force you to, and will say that developers are kind of made a mistake, but that is not true. That is In most cases, that is not true, because by the way, the company gives us money to develop features. Okay, how to start that migration? What is the proper way how to start that migration? Well, first of all, you need to start from the setting the clear boundaries in your part of the code you want to refactor. It can help to avoid you uncontrolled scope, because if you know what you need to do and which parts shouldn't be touched, then you're probably kind of safe. You will be definitely more safe if you set up those boundaries. Write tests on your code. Yes, it might be painful, especially if you have a function which has 10,000 lines of code. It's extremely painful. I really had that experience, but it's really worth to write at least the behavioral tests. Not necessarily tests that function execute the exact code, but at least compare the data sets or the crucial components. What are the real purpose of having that component? How that component acts? There is no such thing like a perfect code. That's actually also a good one, because every time that a new developer comes to the project, they all the time saying, yeah, the code is really shitty, yeah, we need to refactor everything. But that is obviously not all the time true. Yes, the code might have his own weaknesses and strengths, but the code is not bad just because you don't understand that. That's the thing that you need to understand, that you really analyze someone's code, and yeah, maybe that is the case, that is completely a mess, but yeah, you can't just blame people for that. Yeah, try to not refactor large pieces of the code. It will save your nervous system as well as a company's one, because when you have a deliverable value and you constantly deliver, then the progress is measurable. Good communication with product manager or product owner, it really depends on the project. But I really emphasize you to understand that apart from the development, there is a business side of it. And you need to have a communication with your PO, like when you can come to him and say, bro, that code, we waste a lot of time on that, we need to refactor. You need to convince them, you need to speak with them. This is the game, how it looks like. You can't just do things without funds from your company. Yeah, the new functionality shouldn't be created during that refactor. Obviously, when you refactor some piece of the code, the other teams should not develop something on top of it. And there are two main questions that you need to answer for yourself. What exactly problem we are trying to solve? Like, why and how? And the effects of refactor should be measurable. Like, it should be measurable for the business side. The development time will improve, the onboarding time will speed up, the application will work more fast. All of this might be reasonable. And even the code seems to be more readable. Even this might be a valid argument, but it strictly depends on your company. Okay, the technical part of it, I hope it will not be boring as it was before. I will present a couple of things that we used in our project. It's the hexagonal architecture, it's the dependency injection, it's a stranger pattern, and interfaces in Python. And I will start that journey with the stranger pattern. It's a quite popular designing pattern that used, especially when you want to transform your monolithic architecture to the microservices, but it's a lie. It's not only used in that ways. You can simply use it in your monolithic architecture, just providing cascade at the code level. And the cascade basically It's a functional entry point that will act as a proxy or router, which will redirect. I think that picture perfectly explains how the pattern works. Yes, you can start implementing your feature, and both of them exist in the same moment, the old one and the new one. Yeah, I think that one explains it more. Both of them exists for the full time until you remove the old one. Like the new one started functioning normally. You can even redirect some of the users to the new component and check how it acts. Like, is it fulfill our requirements? Is it act as expected? And only if yes, then you can start migrating more and more clients to use your new component, and only then remove the old one. Yes, you need to face with the problem that you need to maintain both components, because you never know when do you migrate all your clients. It's definitely costly for you, but it's still worth to keep both. The hexagonal architecture design pattern that separates your business logic from other components, and with the help of it, you actually extracting the business logic from the purpose of that component. The hexagonal architecture makes your code to use it in more modular way, because you're defining just the purpose of that component, and you're actually hiding the implementation details. And yeah, it's easier to maintain over the time, but you need to really implement it, and it's not that easy, but I hope I will show you some of the examples, and it's not overcomplicated. The dependency injection. I hope that everyone using it in everyday basis, but that's something. The dependency injection in general got popular in the static type languages like Java, but now obviously we can use it in any languages. I think not in any languages. But what does it mean, the dependency injection? It's a technique to decrease coupling and increase cohesion. Yeah, those two scary words are not that scary as you can imagine, because the high coupling means that there is no easy way to disable objects, and the high cohesion means other way around, that you can easily replace objects in the whole communication tube with the other stubs. Let's take a look on the example. You have an API client which initialized from the environment variables. You see it here, it's done in the init file. The same with the service. The service does not receive any API client, but he initializes it just in your init file. And the same thing for the main. How we can improve the code? Basically like that API client now is decoupled from knowing where options comes from. Meaning you can extract the timeout, the API key from whenever you want. I don't want, as an API client, I don't want to know from where you will get the key. You can get it from the config file, you can get it from database, but for me the most important that I will use that key, and if it's valid I will make a request, but if it's not I will say goodbye. That is the most important thing. And the same for the service. Service is decoupled from API client, it does not create it anymore. You can provide a stub or other compatible objects, and function may decouple from the service. Now, the interfaces in Python, it's a bit controversial topic in general in Python, because everyone loves duck typing and no one loves the features that comes from other languages. But in general, there is a way to define an interface using the ABC, the abstract classes. It's extremely simple example, I will show in a moment more complex, but the idea is that you have action. In that case, it's a payment. For me as a user, or even for the developers, it doesn't matter which kind of payment you want to make. Like it's a credit card payment, it's a PayPal payment. Obviously on your platform will offer more ways how the user can pay, but you really can distinguish those things and say that there is one interface. It's important to know that my service provides a way to pay. Yes, it's high-level documentation that with my service you can make a payment. Then you go down and you define that, okay, in that way, in the class credit card payment, I will proceed only operations with the credit card, and the same with the PayPal. In that way, you actually dividing the responsibilities. It's still payment, but you just extract the logic one level down. And okay, let's take a look at a bit more complex example, which I used in my project. There is more informations put in here because it's really close to the production code already, but you have the old documentation. You described how that object actually acts, what are the dependencies. You actually see that in the init method. I have a client which is supposed to make some requests. You have a pydantic models. You see that the show handles obviously will show you some information, and you already know only from interface. You don't see any business logic. There is nothing. But just reading that, you already have an idea how that component is supposed to work. The business details are not really important in that stage, because, yeah, who knows which client. By the way, it's extremely easy to extend such interface. If now, okay, I'm using the Binance as a crypto platform, but if you want to use another platform, the only thing what you need to do is take a look on the interface and implement those methods. Yeah, that's okay. That sounds not that easy task, but at least you know how your component should act. You actually defining the expectations, your expectations as a developer, as a business, from that component. It's a strict rules, because you cannot define the component which will not implement those methods which you defined in your interface. Okay, how in theory, it's now a little bit theory part, but in general how that migration may look like. Let's assume that we are the development process. We have a monolithic architecture, we have some services, the domain less important, but let's assume that is an e-commerce shop which contains the next services. There are two possible scenarios. The first one, you as a team, as a single unit, like you act as a team, and you all, everyone, refactor that exact component. For example, payment. But there are another option, that the team is mixed and everyone from other teams will work on that component, which is less great than the first option, but yeah, let's take a look how it may look like. If you have if you want to extract that component, okay, that's the funny word microservice. Let's clarify. In my opinion, the microservice is not only something that runs in completely separated cloud provider, but if you have your monolithic architecture, you still can have services which can communicate. Yes, they are inside the same network, but it's actually microservices. Yes, they just communicate in your local environments. Okay, we can extract part of the code base into complete microservice. Your developers will have a feeling to work on something greenfield. Yes, because it's not coupled with your main code base. You can use, I will talk in a moment what are the difference between two approaches, but in general, you will have that feeling yes, I'm working on something new, you can do whenever you want. You're basically starting from scratch. What are the difference between those two approaches when you doing something in the complete isolation as a separate service, and when you do something not as a separate service but inside your monolithic architecture? It's a limitation of the tech stack. We can't add a new dependency if you work on the monolithic architecture, but then your dependency will impact the whole application. Yes, because your application is a single unit. Tightly coupled services. If the service is very coupled, even changes in our service, for example, can overload the rest of the application. Testing and debugging, challenges due to lack of isolation. Obviously, if you are in the ecosystem of the monolithic architecture, then any changes will impact others and other way around. Potential for increased downtime and any system changes. Yes, your service in monolithic architecture will impact. And difficulties in scalability. Yes, because you cannot scale only your component, but you need to scale the overall architecture. Okay. Yeah, there is an example how actually the development pipeline may look like. Yeah, obviously it's better when you have a separate pipeline for your refactored components, and it's ideal to have a separate pipeline, but if not, then nothing really crazy will happen, especially you can playing with end variables on your CI/CD and somehow play with it that you will kind of have a separate pipeline, but yeah, it would be nice if no one will touch the part of the code that is being refactored. Okay, how it may look like from the client perspective. From the client perspective, you have that cascade, proxy, router, you may call it as you want, but the main idea that you will redirect the request, the new fresh service. But it's also may sound great, but in practice, it's not that great. Yeah, why? Because a new service may increase the waiting time for the response. Yes, because it's if it's not in a single unit of your monolithic architecture anymore, then you need to wait for the response. You can misconfigure your service and redirect it to nowhere. Also happen. If your microservice, by the way, needs an access to database which is used in your monolith, then maybe it's not a great idea to migrate it to the microservice. It may require additional monitoring for that service. Is it overloaded, not overloaded? The sentry, something on top of that definitely you should implement on your own, because it's now a separate unit. And it's increased the complexity of the system. Yeah, by the way, from one side it's decreased the complexity because you split your logic for the services, but from the other hand, you have more services that you need to monitor and track the health of them. Okay. And yeah, in the same way, if you work in the monolithic architecture, unfortunately that redirection should be done at the code level, because it's, yeah, you need just to redirect that at the code level, which is fine, but not as a microservice. Okay, how do we migrate it actually from ZeroMQ broker, which is, by the way, quite old message broker, which does not support TCP and SSL, I think, out of the box, to the NATS, which is cloud-friendly message broker. In very brief summary, let's assume that it's the current state of the application. We are still in monolithic architecture. We using the message broker somehow named ZeroMQ. it has some methods, like we'll discover each of them, but for example, how the subscriber may look like. This is just an example how it works. It's not something that you need to implement, but I will try step by step improve the code to the last step where it's actually usable. If you consider that option great, it isn't, unfortunately. But yeah, I will show in a moment why. This is an example how the publisher may look like. Pretty much the same, and I would like to improve the code step by step. We went from that, for example, to that. First of all the config files, the environment variables, like the configuration things, should be extracted from your code. You should not use the plain text as it here. You should define them, and it should be configurable, especially if the service which requires speak to other components or should be available through the network. Okay. The next thing, the good practice is to extract your subscriptions, your subjects, your topics. It's called in each broker differently, but the idea is that extracting them to the place like a num or just config file, it's a kind of documentation in place for your service. If you already know how the service acts, what are the dependencies, how do we use our message broker, basically, by just knowing the subscriptions, you will be able to find the usage later on. In short, that slide, it shows how we would implement the enqueued message broker class. Nothing really complicated. As I already said, the dependency injection where you extract all the things which are not related, like the configuration file, the configuration variables, like the hostname, port, type. Everything is extracted to the out of the main engine, basically the message broker. For me, that's important how you would get those values. You can get it from where you want. Just give me them, I will validate and respond you if they valid and I'm ready to publish, subscribe or not. And yeah, and you defining the two methods. Basically, how you would do that? You look on the usage of message broker in your code base. Which methods do you use? Do you use a publish, subscribe? Do you use the request, reply? You just collect all of them, and you're trying to implement kind of interface. It's not interface yet, but you're implementing the logic of how do we use that component. Once it's done, that example of dependency injection library, it's rarely used in production. Unfortunately, I have never used in my professional experience, but I found it really extremely useful. In that way, you can define your containers, the containers in a sense that you can replace and use them as a separate component, by the way. There at the bottom, you see how we can use it. What we need to do is to initialize it, and it's ready to go. But it's completely decoupled from everything. Like, you just know that I have a message broker, I want to publish. You just use it as a publisher. You don't want to play around it and trying to initialize what are the values. That info is hidden from you. You don't necessarily need to spend time investigate how I need to initialize everything to make it working, but it's working out of the box. If something doesn't work, the overall system will not work. It's kind of consistency, because you defined it only in one place, and you can use it everywhere. Okay. There are obviously some pros and cons, but I will not maybe go that much into details. But yeah, you can play around with the dependency injection library. There are many of them. They are integrated with the different frameworks like Fast API, Django, or others. But yeah, you can play with it. Knowing how do we use our component, by the way, everyone is saying that the interfaces is something that you need to implement. It's your domain. You need to implement that before any business details of your code, like the business code, like the business logic. But that is not true. How you would implement something like the interface, how you would implement the component without knowing which problems you will face during the implementation. That is ridiculous. It's never worked in my project that you have a clearly defined interface, then you just implement the business logic and you didn't touch interface. It's a lie. In practice, in most cases, it will not work. But where the interface is actually a good fit, I really think that is a perfect fit, is when you already know how do you use your component, then you write an interface from it. Because you already know how to use your components. That writing an interface would just be a documentation in the code for developers, and it will simplify who knows if in a couple of years there would be another fancy message broker that we want to migrate. But we already know the interface, we already know how do we use it. We know the subscriptions, we know the responses, we have defined a format. The only thing, once we have the message bus, what we need to do is that implement basically something NUTS specific. In that case, it was NUTS, the business logic goes in that methods. Nothing really complicated. The init method may be different, but the most important is that we will use the same methods as it was before. We already know them. We didn't miss anything. And as a result, also obviously, because we were in the monolithic stage, our Cascade, the proxy, the router was implemented in a code level. It was just an adapter, which based on your input will redirect some traffic to the right message bus. And in some cases it was still redirecting to the 0MQ, but in some cases it was redirecting to the new component. And in that way, we migrated half of the clients to the NUTS and see how it acts. And then, if everything works fine, we redirected the next half of the clients, which makes sense. It was kind of safe approach. And what we have at the real end? The real end looks like that. Yeah, that's the hexagonal, unfortunately, will more bigger than the slide. But in general, you have your core application, you have still working your two message brokers, the RMQ1 and the NUTS, both of them following the same interface, and on top of that we have an adapter, which maybe it's even better to call it a router, but in general it's based on your input redirect to the correct message bus. And that was an idea. It's a safe approach, and I think that we can dive straight into the pros and cons of that approach. The pros, that you definitely reduce risks during the refactoring. That's obviously if you keep both components functioning. Yes, it's costly, but if you keep them both, then you will be more safe. You keep the old services in play to updated versions. Allow to quickly deliver business value and achieve visible results. I put quickly in quotes because unfortunately it might be even longer if you would go with the safe approach, but the effort is worth it. Documentation in place, obviously when you introduce new components, or even if you read the old code, and you probably will leave after some documentation after you understand how actually the system works. The cons, there are more cons I think, yes. It requires a lot of ongoing attention to routing. Yes, you need to play a bit with it, you need to, when you have a different message brokers, we face the problems with the wrong data formats, because there were different types of the formats that the NAS and the RenQ accept, and you need to reformat it, and you are doing that by your hands, unfortunately, and sometimes you can break something. A refactor effort can get stuck in adapter hell. That is also true, that sometimes you will more and more add things to your code where you have the creepy if that then that, because you need to properly redirect, and yeah, who knows if we made a mistake somewhere. Requires making sure that you have a rollback plan in play for each refactored instance. That is definitely true. Yes, you need to have your play rollback mechanism. What will happen if the customer faces some issues with your component? Would be nice if you can change the environment variables and it will recover automatically. This is how we did that, by the way, based on the environment variables. It was loading the new or old version, and it was extremely easy to change. You don't necessarily need to customer don't need to wait. Okay, he actually need to say to us that, okay, something wrong, or we can search for the issue in the log files, but the changing of them was extremely easy. It's just based on environment variables, the new or old version. Not easy to modularize application if components are tightly coupled. In case of the message broker, it was, you can say that it's tightly coupled with other components because it's just a tool which you use, but sometimes your component, the real sense your business component, might be tightly coupled with others, meaning that you have a simple endpoint which interacts with others, and it's really hard to maintain such things, I mean to refactor such things. And the infrastructure and development costs. That's, as I said, it would be much faster if you would not write any tests and write tests only on the fresh environment or fresh component. It would be much faster if we have one pipeline for everyone with no restrictions and everything. But it's, in my opinion, you will pay much more money than for fixing customer bugs than you will pay for on your. You will actually invest in your proper development process, like proper refactor process of your component. And that's it. Yeah, that's it. On the left side, on the right side, on the left, on the right. On the right side, you see the QR code. We can keep in touch. On the right side, in the morning, my colleague has a presentation about decentralized cloud, where you can upload your photos in decentralized way. If you want to talk about the decentralized cloud, we can stay after the presentation and talk about that if you're interested, what are the benefits, the pros and cons of it. And yeah, that's it. Thank you very much. And now I think I will open the questions. I hope there's some. Yes, there's some. Okay, let's go one by one. How do you enforce interfaces MyPy? The interfaces like that ABC thingy will enforce you to implement the methods. It's not just static type checking. It will, if you, I'm Still sharing? Okay, it's complicated. But if you define your interface that your payment should have a process payment method, then if you inherit from that class, then you're not able to initialize it just because you're not following the interface. It's Python do out of the box for you. But I think what was meant here is that sometimes instead of interfaces, you can use prototypes. It's also the Python types, which will not enforce you to implement the prototype, but the static type checker, like MyPy, as it mentioned here, will yell on you. He will say, hey bro, you're not following the interface, but it will not break the application. But with the ABC, it will break. Like it will fail. Okay? How do migrate database transaction? Monolithic may update several things autonomically. How do you achieve that with microservices? Do you use sagas? Yes. Yeah, as I said, that example was with monolithic architecture to the modular monolith. The database transaction is the most painful problem in microservices architecture. Yes, the saga is one of the way. Who doesn't know what does it mean saga, is that when your one service successfully finish his job, he will commit to his database. But also what he will do, it will have the rollback transaction opened, let's say it like that, and wait until if any of the next services will fail, each of them will recover, like the rollback the transaction what was successfully committed. It's really hard to implement. In general, you will have probably the huge number of problems with it, but at least there is a way how to solve that issue with database transactions. But in microservices, it's always the problem. Are you using manual dependency injection, or do you have a library for that? I'm using manual one, and I would say I recommend to use the manual one, just to not increase the tech debt. It really works nice. If it depends on your goal. If your goal is to make your code more modular, more readable, then the manual dependency injection perfectly fit. Like, it's a perfect fit. Your code will definitely be more understandable for everyone. Adding the previous question for dependency reuse, when multiple objects need the same dependency, do you create duplicate dependency object or the same? Yeah, it depends on which type of architecture. Sometimes if it's microservices, sometimes it makes sense to duplicate them just to decrease that coupling path. Still, how you would deal if the one service, that dependency act in another way? How you would solve that problem? Then those dependencies should somehow know about each other, because they should be implemented in the same way. They should be consistent. It's a tricky problem, which definitely will appear when you have the microservices architecture. But answering for that question, there is no one answer. Like, it really depends on which type of the dependency, because if it's a tool, then it doesn't really matter. But if it's the code, then you probably need to versioning of them. You just need to use other techniques to have them consistent. Where do you keep interfaces definition? What is your directory structure that this project? The interfaces usually I put in a file name called interfaces. Pretty much clear and understand for everyone. You have an interface, you open the directory, and you see all of them in the root directory of your file. Oh, very nice MacBook. And I think that's it. Okay? Yeah, thank you everyone. Very nice. Thank you.